Godot 4.5 is released. Let's go through the blog post. Making dreams accessible. From mind-blowing effects now made possible by the stencil buffer to accessible description of your GUI elements that opens up the possibility for people with disabilities to play your game. We are proud to present to you Godot 4.5. With this new release, we made meticulous efforts in order to amplify what is possible to do with our engine, guided by our goal of making gaming and game development for everyone. Before transitioning your existing projects to Godot 4.5, carefully read our migration guide to learn more about breaking changes. So yeah, here you can download. I'll just download this. Okay. Made possible by your donations. So highlights: open your eyes for new effects. Stencil buffer support. How do we visually drill a hole in that wall in order to peep at the player on the other side? You can now do it with stencil buffers. Imagine an invisible sphere that surrounds our character. Even if geometry is not rendering itself on screen, we insert its shape into stencil buffer. Then we make our wall shaders only render if the target pixel is not covered by the stencil. Voila! A stencil buffer is a special buffer that meshes can write to for later comparison. It is similar to the existing depth buffer, except arbitrary values can be written and you have more control over what you can do with comparison. Show, don't tell. Screen reader support, a feature often overlooked that is must have in computer software, is screen reader support. Such readers are an essential tool for people who are visually impaired, illiterate, or have a learning disability. Thanks to Access Kit, we have added screen reader support to control nodes, and we have also added screen reader bindings in order to customize the behavior of any type of node. As this feature is quite new, please note that its integration is still in experimental phase. And screen reader support for Godot editor itself is not complete yet. It is only implemented for project manager, standard UI nodes, and the inspector. Expect follow-ups in future updates. Down the rabbit hole: script backtrack tracing and custom loggers. Script backtracing gives developers the exact details on where an issue happened in the code, even in release builds. Custom loggers allow developers to intercept log messages and errors. That makes it possible to create a tool for reporting bugs within your game. Developers and players will now be able to report issues containing more accurate information of its origin. Preheat the oven shader baker. Anyone that plays modern game, especially on PC, has the experience of waiting for shader compilation. Usually it shows up in two forms: either the game makes you wait when it first launches, or it makes you wait right in the middle of the action. That's because shaders are small programs for your GPU that draw the current scene, and they need to be compiled in order to be used. While pipeline compilation is still unavoidable and a requirement, Godot now offers a way to do everything that can be done via the editor ahead of time, reducing such wait times by a lot. Where Uber shaders were a big step towards optimizing pipeline compilation and eliminating compilation stutters, the shader baker addresses the long startup times. When enabled in the export settings, the shader baker will scan resources and scenes for shaders and pre-compile them in the right format used by the driver on the target platform. When targeting Apple and Windows devices using Metal and D3, D12 respectively, we saw even a 20x decrease in load times for our TPH demo. Talk about fast. Internationalization live preview. This feature is key to our ideal of making game accessible for everyone. From now on, developers will be able to preview translation directly from the editor viewport. This will ease the burden of testing the GUI in multiple languages. How does your new UI react to being in French or Dutch, or how does it look in simplified or traditional Chinese, or even in Hindi? General 2D fusion, chunk tile map physics. Ever since 2D tile maps were first implemented, physics always relied on the concept of one tile, one body. While this works for most games, it can easily lead to performance issues in 2D scenes. Relying on physics as the number of bodies is extremely wasteful. The system has been reworked from the ground up. Now tile map layer physics merge cell shapes into bigger collision shapes whenever possible, as deep as you wish. Duplicate at ease with expected results. For a long time, even though research.duplicate has deep parameter, people realize that setting it to 2 doesn't always perform in a reliable, predictable way. Notably, it does not duplicate sub-resources stored in an array or dictionary with properties. The same thing happens with array.duplicate and dictionary.duplicate. The new duplicate deep methods for these classes now gives user full control of over what gets duplicated or not. This new feature is the result of an overhaul of the duplication logic for arrays, dictionaries and resources. For developers, we made sure to keep what was working and consistent intact. If you need more details, feel free to consult our new exhaustive documentation about the duplication specification. Tailor fit the engine for your projects with this build profile improvement. Since Godot 4.0, users can open project customization engine build configuration to access the edit build configuration profile window. This utility helps with selecting and even detecting which classes, that is which nodes, resources and servers are actually needed for the currently open project. The idea is that by reducing the features to not only the ones actually needed, users can build their own Godot template that is custom fit for their game. 4.5 expands on what is detected. Not only does it detect classes, but can also now set correct build options. It also takes into account which classes are used by the project's GD extension. Editor. Mute game toggle debugging can be tedious, especially if it exposes to the developer to the same music over and over. One could turn off the speakers entirely, but that's not really practical, is it? To keep everyone's sanity, we introduce the new mute game toggle located in the game view. May your ears enjoy these new opportunities of quietude. Drag and drop resources in scripts to preload by UID instead of by path. With Godot 4.4, we extend the UID support to more resource types in order to prevent broken paths. Scripts can now take advantage of this by preloading resources via their UID. You just have to drop the resource while holding Control Command on macOS. By using UIDs instead of paths for preloading, your scripts will be more resilient whenever the resources you are preloading are in your project. Allow selecting multiple remote nodes at runtime. The new embedded game window introduced in 4.4 highlighted an issue the editor had for many years now. The remote node list didn't support selecting more than one item. This is now a thing of the past. Developers can now select multiple nodes and even edit common properties. Editor language can switch on demand. Changing the editor language no longer requires an editor restart. These features can be quite handy for editor plugin developers testing their translation. For everyone else, you can test the editor in all the languages it supports. Export variables as variants. With this new update, it is now possible to export variables as variant. Previously, a variable could only be exported as a variant if it had an initialized value. Also, the editor would stick to the actual type of said value, making it impossible to change the value to another supported variant type, such as string or color. Now, if the exported variable is of type variant, the editor reacts accordingly, permitting the user to assign any compatible variant value. There is even a nifty type selector that changes the input weight accordingly. Go inspector section. Toggle inspector section. As a user experience upgrade, we replace the enabled property within groups with an intuitive checkbox beside the section name. You can now easily see which sections are enabled, even collapsed ones. Plugin developers can use this feature in their projects using the new property _hint_group_ enable. Script color picker. Not everyone can read color, so we have added a little color preview next to every color value. We even push the idea further. If you click that preview icon, you can edit the value on the spot using a color picker. Execute editor script using the command palette. Any named editor script file in your project now appears in the command palette, making it much easier to execute specific project commands. Paste as unique option. When copying and then pasting a resource in an editor inspector slot, it usually pastes a reference to the copied resource. If you wanted a unique copy instead, you had to manually click and make a unique afterwards. Now the new paste as unique option available in the resource picker dropdown makes the operation way less tedious. Duplicate project straight from the project manager. There is now a dedicated duplicate button in the project manager, making it easier to back up an existing project or to fork a new one. We also figured out that it would be a great tool to prevent losses if you update the engine version during development. If we detect that irreversible changes would occur due to the update, will ask you if you want to back up your projects first. Append signal source automatically. This will help unbinding signals from their source and make code reuse far easier. So when connecting signals in the editor, you will notice a new append source option in the advanced setting. If this checkbox is enabled, the source object will be appended right after the original arguments of the signal. Animation player quality of life upgrades. The animation player has received some much needed love. You can uh, use the selection box to select and scale Bezier editor points. Now it's a piece of cake to perform batch changes. When creating Bezier points, you can auto tangent new points in a balanced or mirrored manner. You can sort the animation players animations alphabetically. It is also possible to filter animations by their name. Icons now look sharper than ever. DPI aware icons. The default controls and editor UI tended to look blurry on HD high DPI screen. We rework the rendering of this component in order to make them look sharp on every screen. Cascade content easily with foldable container. The new foldable container nodes and adds an easy way to display a lot of details at the discretion of the user in an accordion view. It even supports grouping, making sure that only one foldable container is open at a time. Label stack effects. Style labels as much as you want with Godot 4.5. We added support for stack layer of effects. No cumbersome workaround required. You want it outlined with complex shadows? Done. GUI GUI no more. Handle a complex GUI easily with recursive overrides. It is now possible to change mouse and focus behavior of a control node recursively. This greatly helps creating complex GUIs without breaking a sweat. Here's an example. Let's say you create an inventory screen for your game. On the left there is a grid displaying what is the hero what carrying. On the right it shows a detailed view about the selected item. On the left a rotatable display of the item in 3D to examine every detail. A section containing a scrollable description, a box containing stats and modifiers with hyperlinks for technical terms, and a list of buttons representing actions that are possible to do with it. Now the problem is that the right view depends on an item being selected on the left. The user shouldn't be able to interact with the detail view until that happens. By changing control.focus behavior recursive and control.mouse behavior recursive of the detail view container to the disabled value until an item is selected, focus and mouse events will be disabled for every child. You no longer have to resort to complex messages to manage the behavior of control groups. But thou must added required qualifier. When extended, some classes need some virtual methods to be overridden in order to work, but it wasn't always obvious in the documentation. This won't be an issue moving forward, as now the required qualifier will come right after the virtual where applicable. Platforms. Android. The UI adapted for non-desktop users. Virtual keyboard users can attest to the desktop-oriented nature of the editor UI. Common actions such as undoing and saving are tedious to execute, as they require opening up the menu bar each time to find the action. With the new touch action panel, tablet and phone users now have direct access to common action button. The feature is currently Android only, but we intend it to port to other platforms as soon as possible. Supported for devices with 16 KB pages. Computers have few tricks up their sleeves to handle gigabytes of memory. One such trick is paging memory in discrete blocks so that system can quickly jump to it when looking for a specific address. Pages can come in multiple sizes depending on the platform. Since its inception, Android only supported 4 KB pages, but the Android team recently announced compatibility with 16 KB pages from Android 15 onwards. Developers should note that though starting on November 1st, 2025, Google Play will require all new submitted apps targeting Android 15 to support 16 KB pages. Fortunately, we have got your back. Godot 4.5 supports this feature out of the box. H2H support. Usually developers have two choices for displaying content on the screen. Either their app leaves the top and bottom areas for the system status and navigation bar, or their app could go full screen, claiming all the space without displaying these bars. From now on, there's a new export option. Android has a feature called H2H display. It offers developers the ability to draw on the entire screen as if it was full screen, but with system bar overlays. This gives your game a more modern look that matches Android design system. Camera feed support. Godot now supports accessing the device raw camera feed on Android. This enables developer to access live camera input and process the data for any purpose they want. From cute face filters to AR, the possibility with these features are endless. Bake lights and UV unwrap on the go. Baking lights and unwrapping UVs with the Godot editor is no longer only limited to desktop OSs. You can also do so on your phone or tablet. If making games on mobile device is now entirely possible, what's preventing you from creating the next blockbuster? Linux, a window is worth 1,000 words. Native Wayland sub-window support. Sub-window support means that Godot can now spawn new independent windows when running on VLAN natively. This was also an important and not a small hurdle to cross in order to achieve game embedding in the future, which is already been worked in this PR. Apple game embedding support on macOS. macOS Godot users can enjoy the embedded game window introduced for some platforms in 4.4. Export to Vision OS. You can now export for Apple's XR platform Vision OS, making Godot projects compatible with Apple Vision Pro. Godot 4.5 marks the first steps of Vision OS native integration. For this, we would like to thank Apple's Vision OS engineering team for their contribution, adding support for their operating system to Godot engine. This is a big deal. Vision OS is the first platform supported natively by Godot since the project was open sourced. Currently, it is only possible to export a project as a windowed app. Your game will appear as a window floating in the user's 3D space. We expect to support fully immersive experiences in the future. Windows so long are sedit, modify metadata without RCEdit. Windows.exe file metadata such as custom icon, the product name and company information is stored internally as resources. For years, in order to modify these resources, the window exporter needed to access an external window program, RCEdit, that made it difficult to export for Windows on a non-Windows machine. But now the Windows exporter knows how to handle the resources natively, so you can edit Windows export metadata without a hitch on every platform. Web free performance boost. WebAssembly SIMD support. For about 2 years now, all major browsers have supported WASM SIMD. SIMD stands for single instruction multiple data and is a technology that permits CPU to do some parallel computation, often speeding up the program as a whole. Starting with 4.5, you can expect your web games to run a bit more smoothly without having to do anything, especially when things get chaotic for your CPU. It isn't a silver bullet for poorly optimized game, but it will help nonetheless. Scripting. C#.NET. Straight from the source, loading .NET assemblies directly from Android APKs. Assemblies are building blocks for any C#.NET application, as they provide types and resources for different functionalities. Functionalities range from system I/O utilities to your own game logic. In the past, for Android, we have been extracting the .NET assemblies from the exported APK and stored them in cache. While this works well on other platforms, it caused issues on Android such as outdated assemblies or permission errors. We now load those assemblies directly from your APK, which solves all those issues. GD scripts introducing variadic arguments. GD script functions can now accept an arbitrary number of parameters. You can't touch this. Abstract classes and methods. You can now declare GD script classes to be abstract. Declaring a class abstract means that the class is not meant to be instantiated directly. This means that you can prevent instances of a class, let's say animal, that doesn't have any purpose on its own other than to be extended by concrete classes like cat and dog. Abstract classes can also have abstract methods. This means that the method must be implemented in any class that extends it. GD extension. Main loop callbacks. GD extension plugins sometimes need to run code at a specific engine queues. For example, there were a lot of issues accessing this engine singleton from GD extension since there was no simple way to know when the engine had started up or shut down. From now on, developers are able to register main loop callbacks directly from GD extensions such as startup and shutdown. This new feature is the result of our ongoing efforts towards bringing C# and .NET to GD extension, as the port needed to register a frame callback. Systems animation. Bind bones to other bones with bone constraint 3D. With bone constraint 3D and the new A modifier 3D, copy transform modifier 3D and convert transform modifier 3D. It is now possible to bind bones to other bones. This can help more natural movements and poses. This feature is really helpful for handling VR and metaverse avatars. Import. Reintroducing batch editing of assets. Want to quickly change the same import setting for multiple resource file. We introduced options in the import doc for batch editing of assets. Now when you select files in the file system doc, the import doc will let you select which properties you want to edit. With a single click of the re-import button, your new import settings will be applied to all selected files simultaneously. Input. HDL3 gamepad input driver. The gamepads are given in a modern PC gaming. User expect their gamepad to just plug in and work. Not only that, but in order to deliver unique experiences, some gamepads are introducing new features from adaptive triggers and advanced haptic feedback to microphones and motion controls. Over time, issues accumulated in our gamepad driver implementation and missing features began to crop up. We were facing an ever-growing mountain. That's why we turned our head to the HDL project. HDL is a well-established and mature cross-platform library that handles audio, keyboard, mouse, joystick, and graphics. We determined that it's now a net positive to defer the responsibility for gamepad handling to it. While this change doesn't by itself bring new feature, expect bug fixes and new features to come a little bit faster from now on. Dedicated 2D navigation server. Ever since its introduction in Godot 4.0, users and navigation node interfaced with the navigation server 2D for all that 2D path finding needs. But what if I told you that navigation server 2D was hiding something? Previously, navigation server 2D was effectively a proxy for navigation server 3D. It used the 3D navigation logic but with everything constrained to 2 axes. However, this has an important caveat. Pure 2D games using a navigation required an export template that had 3D support. That would obviously pump the final export size of their game. We finally managed to create a dedicated 2D navigation server. Users will be able to tweak their 2D and 3D navigation servers independently, process navigation regions asynchronously. The main thread of a computer program is like a project leader. If the project leader handles too many tasks and doesn't delegate enough, it can affect the overall performance of the team. Enabling async iteration asks the navigation server to delegate the navigation process to a background thread, which can improve overall navigation performance. Frames goes on trees now. Scene tree 3D physics interpolation. We transplanted, or should we say crafted, 3D physics interpolation to scene tree. Introduced in Godot 4.4. 3D physics interpolation is the concept of making physics based movement appear fluid even if it's running slower than the process frame rate. We previously implemented that feature in the rendering server, as the feature is mostly tied to drawing in between states and it didn't require changing code handling nodes. Unfortunately, this caused some issues, namely in practice, Godot's built-in nodes and custom nodes often rely on node 3D transforms for their behavior. Due to technical and performance related reasons, it proved impossible to query the rendering server for interpolated transform. We had to move everything to scene tree for 3D where nodes reside. Not only has this a fixed number of issues, but it also makes everything conceptually easier for users and maintainers. Don't worry, what's awesome is the fact that we keep the existing user API even if a lot changed under the hood, so this change shouldn't break your project. Added realism for cheap. Specular occlusion from ambient light. Ever wonder why some objects would eerily shine as if they were hit in a occluded area where they shouldn't? For example, a common stumbling block for users is seeing light from the sky get reflected in the cracks between bricks in a brick wall. That's because the calculation of the light reflected off the surface didn't make ambient occlusion into account. Fortunately, our renderer now has a cheap option for specular occlusion that should fix this issue. For existing project where it could break the loop, don't fret, a toggle is available in the project settings. Introducing the normal bender. Beat normal map support. In a rendering jargon, a normal is a 3D vector which is perpendicular to a surface. A normal map is a texture where each pixel of it represents a normal using the red, green and blue intensity as the vector axis views. Normal maps are often used on models to add surface details without having to make the meshes super detailed. If the normal map describes a bump, the lighting system will make it look like there is one even if the underlying polygon is flat. Best normal maps are similar as they are textures representing 3D vectors each pointing at something. The normals are considered bent because instead of being perpendicular to the surface, they actually point towards the direction of least occlusion, that is the direction with the least amount of stuff blocking the incoming light. For example, if a theoretical bent normal map was created from inside of a cave, each vector would point towards the opening. What does it mean? Why should we care about the direction of least occlusion? This information is extremely valuable to the renderer. It is used to further enhance specular occlusion. Darker areas that shouldn't be receiving a lot of reflection and indirect lighting provide more accurate reflection. SMAA 1x support. Sometimes add-ons are so good that they get promoted and included directly in the engine. This just happened to the Godot SMAA add-on. Subpixel morphological anti-aliasing is a modern post-processing based anti-aliasing solution to get rid of those pesky jaggies. It provides sharper AA than FX AA at the trade of being more resource intensive. This is one step in our quest to improve the built-in post-processing effects in Godot. Mobile renderer now using half precision floating point format explicitly. If a computer can only understand zeros and one, how can it calculate non-integer numbers? That's where floating point arithmetic comes in. It's a method to represent this kind of numbers in binary. A mobile GPU not only needs to process pixels as fast as possible, it needs to do it in an energy efficient way. Quite recently, the industry realized that even the standard single precision floating point F32 format can sometimes be overkill in terms of sizing and processing power, even for rendering process. With this new update, the mobile renderer now explicitly asks for half precision floating point format if the hardware supported. Most devices commonly used should, especially if they are new. If so, games should now see rendering performance increase, run smoother overall, and requires less power usage. Support for D3 D12 OpenXR backend. We added a new backend for OpenXR. You can now render your XR projects using D3 D12 on Microsoft platform. Foveated rendering on Vulkan mobile. In order to push great visuals on a VR headset, a little cheating is often necessary. The human eye sees more detail at the center of your gaze and less around your peripheral vision. So why we should render the edges of the viewport at full resolution? This is called foveated rendering, and it's something Godot has supported with OpenGL or Vulkan on desktop via the fragment shading rate extension for a long time. However, now support for the fragment density map Vulkan extension has been added, which also enable this on the Vulkan mobile renderer, making it more viable option for standalone VR headset. Application space wrap reporting for DOT. Mobile headset resources can be sparse, so it's important to know how to optimize the compute budget. Because XR requires a high refresh rate, developers are left with a limited time frame to render. But what if we could use frame synthesis to our advantage? We could render at half rate while the GPU synthesis the next frame, keeping the targeted frame rate as a whole while giving ourselves effectively much more time. That's exactly what Meta's application space wrap does on Meta and Pico headset. We now support this technology with the latest release of our OpenXR vendor plugins, thanks to the implementation of motion vectors in the mobile renderer. As OpenXR just released the multi-vendor frame synthesis extension, we expect support for more headsets in the future. OpenXR render models. We have added support for the XR EXT render model and XR EXT interaction render model extensions introduced in OpenXR. These extensions, when enabled and supported, give an application access to fully animated models of the controllers currently held by users. This means MetaQuest 3S and Pico 4 Ultra users will see their respective controllers in their hand without extra effort from the developer. In order to use this feature in your game, you need to add OpenXR render models as a child node of the XR Origin 3D node. For more information, please see the docs. Special thanks, Teamworks makes the dream work. So here are all the contributors who had their PR merged into the release. The names are ordered alphabetically and sized according to the number of contributions.